Alright, for this problem we're given the probability density function of continuous random variable x is given by the function f of x equals x times e to the power of x, for x is greater than 1 and less than alpha. And we need to find alpha. So pause the video now to solve this on your own. Alright, so first we need to keep in mind the property of a probability density function that the total area of its domain is equal to 1. So we can represent this as an integral from 1 to alpha, which is its domain. So we'll have the integral of 1 to alpha of x times e to the power of x dx. So to solve this integral analytically, I'm going to use the DI method over here. So we have DI and plus minus. So I'll be differentiating x and integrating e to the power of x. So the derivative of x is 1, and the integral is e to the power of x, and we see we can integrate these two. So this is equal to 1. So this integral is just going to become x times e to the power of x minus the integral of e to the power of x dx. This is all going to be evaluated from alpha and 1. This is still equal to 1. So we see this is simply going to become x times e to the power of x minus e to the power of x evaluated from alpha to 1, and we set this equal to 1. So now we see when we evaluate this at alpha, we get alpha times e to the power of alpha minus e to the power of alpha. Now we have to evaluate at 1, and we get e to the 1 minus e to the 1. This equals 1. So now we see this will just become 0. So now we just have alpha times e to the power of alpha minus e to the power of alpha equals 1. To solve this, I will first factor out e to the power of alpha. And this will just give us alpha minus 1. This is equal to 1. So to solve this analytically, I will use the Lambert W function. So over here, we have Lambert W function, which states the Lambert W of x times e to the power of x is equal to x. So over here, to make our exponent and our product the same, I will multiply by e to the power of negative 1. So this will just give us e to the power of alpha minus 1. This is still alpha minus 1, and on this side we'll have e to the power of negative 1. Alright, so now we can simply take the Lambert W function of both sides. We'll have the Lambert W function of alpha minus 1 times alpha minus 1 equals the Lambert W function of e to the power of negative 1. So we see this will cancel and just give us alpha minus 1 is equal to the Lambert W function of e to the power of negative 1, or 1 over e. So our final answer is just going to be alpha equals the Lambert W function of 1 over e plus 1, which is approximately 1.27846. Alright, so over here I have the Desmos graph of this. So f of x is equal to x times e to the power of x, which is our probability density function. I have set up g of x as our integral, where x is representing alpha. And when we solve for h of x equals 1, we're finding where this integral is equal to 1. We see it gives us the same value of alpha as approximately 1.27846. So thank you for watching the video. Make sure to subscribe to the channel if you enjoyed this content.